so let's go to the lesson. It should be relatively short-ish. If I asked you, this is not the lesson at all. What in the world? Obviously, I made changes to the lesson, and I did not change the slides. Yeah. Hang on 1 minute. Sorry, I opened the wrong slide. Sorry. Lo siento, mijos. All right, so let's start here while I'm getting up the right slide. Tell me, what is pi? I have a point, I'm not just wasting time. What is pi? It's an irrational number. That's a description of pi, but what is pi? That's what pi equals. All right, now we're talking. It is the ratio of the circumference to the diameter. Sorry, wrong slides. Okay, so it's the ratio of the circumference to the diameter, and that's true. So, who invented pi? Who invented America when we came along? America invented America? There, okay. Who invented the moon? So my point is, nobody invented pi. It was there, and it was discovered. It is a naturally occurring number. Same goes with E. E is a naturally occurring number. It's not a creation of mankind. It was just there. It happens naturally in life. And in a lot of ways, it's amazing. It was around since 1400s in England. Napier had this idea of E and natural logs. But once calculus came along, it's even more important because E has an amazing property or two in calculus. Yes?
How did they find E?
Good question. Well, I'm so glad you asked. Thank you. Here we go. Let's look at this from a money perspective because this is the best way to start keep. So, go back to pre-algebra with you, and if I told you you had $1 and invested at 100% interest, compounded once, how much would you have after 1 year? $2, because you started with $1. And when you go back at the end of the year, you get the 100% of the original number back. This is the original is still there, plus 100% growth. That, in essence, means that dollar grows by a factor of 1 plus 1, or 2. All right. Now that's compounded once. But that's not very good compounding. It would be better financial strategy if after 6 months you say, hey, wait a second, man, you've been using my money for 6 months. I want my interest share after 6 months. Now that would be compounding twice a year. Now let's think about this. I don't really like what I wrote here, but let's write it up here. After 6 months, I'll say the balance after 6 months. As far as what I get back or what I have in my account, I still have that dollar. And as far as where it is and how it's grown, I still have 100% of what I have. But after 6 months, it'll grow by 50%. Now I'm going to write that as 100% growth, but only for a half a year's growth. So after 1 year, I would have $1 growing by a factor of 1.5. Where after 6 months, I would have $1.50. Yeah? Right. Now, compound interest is the idea that now for the next period of time, I don't just earn interest on my original amount, I earn interest on my original amount and on my interest. So for the balance at 12 months, I'm going to take my previous balance, and it's going to grow by a factor of 100%. I'm going to get everything I had back, plus another 100% interest for a half a year. Now, if I were to look at that, then that would really mean that after 12 months, I had 1 plus 1.5 from the first 6 months, growing by a factor of 1 plus 1.5, 1/2, or 1 plus a half squared. What is 3/2 squared? 9/4. Or money, $2.25. Oui? Wow. Okay. Now, an even smarter person, probably one that said, you know, that 2 times a year steak, let's go 3 times a year. That'll get richer. So, if you compound 3 times a year, then so if you compound 3 times a year evenly, then when's the first time you're going to compound? 4 months, you're going to get the dollar growing by a factor of 100%, plus after 4 months, you're going to only get 100% divided by 3, or a third of that 100%. It's 100% per year, but it'll be only 100% divided by 3 for a third, right? That then would be 1 plus 1/3 for the first 4 months. The balance after 8 months then would be the previous balance previous, times 1 1/3, times 130%, or 1 1/3 squared, and most importantly, the balance at the end, after growing 133% each 4 months. You get 133% of 133% of 133%, and that is 64.27. So somebody be my calculator person. That's 1 plus 1/3 cubed. That's 4 thirds cubed. 64/27. What is that roughly in a decimal form, please? 2.37037. Okay? But if you invested $1 and compounded it 4 times a year, let's just jump to the end product. At the end of the year, it would be 1 plus 100% divided into how many equal parts? 4 parts. How many times? 4. That then is 5/4 to the 4th, 625/64. What's that? No, 625, 256, which is what? 5/4 to the 4th, please. Who's my calculator person? 2.442. Okay. How about after 12 months? If you compounded 12 times, once every month, then what would the calculation look like?
13, 12,
1 plus 1/12. What's this one for again?
the initial.
That's the initial. You get your original 100% back. Yeah. This then is what? Yeah, that's the interest. It's 100% divided among 12 equal pieces. How many times though? Because it's compound. Well, what's that equal to? 2.613. What if you compounded your dollar daily? You said, forget that. I want every day. I want you to recalculate my new balance. What's your balance? 1 plus 1/365 to the, which is?
It'd be around 2.6.
2.715. Okay? What if you compounded every hour? 1 plus 1/365 times 24 to the
265
what is it, please? 2.718. Okay? Now, if you compounded it continuously, I mean every second, every nanosecond, then what? What do you do? We want to say, what does this approach? So, no, that's not what I mean. I mean, the balance approaches whatever happens as I take the limit as x, or let's go n goes to infinity of 1 plus 1 over n to the n.
Okay, I'm not very good at this.
That is what e is. That's e to the first. Okay?
No.
E is the definition of, no, the definition of e is the limit as 1 plus 1 over n goes to the n, as n goes to infinity. This is an indeterminate form. He's teaching us in kind of a wacky order here. We haven't learned this indeterminate form, but as n goes to infinity, what does 1 over n go to?
0.
0. So wouldn't the base go to 1 and the exponent go to infinity? This is an indeterminate form we haven't learned yet. Usually it relates to e, not always, but usually. Okay. Now, a large part of today's stuff will be kind of manipulating three famous limits. Now, this is good skill to have because you're going to need to be able to take a known definition and tweak it a little. I told you last week that if you look in the back of a college textbook, there's a table of integrals that's usually 3 pages long. And you'll see one that kind of fits what you want to do, but you need to tweak what you've got a little to make it match. So this idea of tweaking a little that's probably given to match a known template or formula is a useful one. That's the idea of the day, besides the definition of E. So first, though, you should have 3. Any calc student worth their salt should know 3 limits like they know their own mother walking down the street. You should recognize them just like that. And one of these is the limit as x goes to 0 of sine of x over x. I would bet you've probably done that 37 times already. Okay? Now we could certainly do that by L'Hopital. And we could definitely do that by calculator and say what happens. That's probably what you did the first time you saw this. But we know that this equals 1. Okay? That is one of the most famous limits there is. Now, you might use this in physics a lot. When you talk a really tiny angle, sine of that angle is just about equal to the angle itself. That's really what this is saying. When the angle gets really, really small, the sine of that angle is pretty much equal to the angle. If you look at the sine of 0.01 radians, it's about 0.01. And if you looked at the sine of 0.001 radians, it's about 0.001. The angle, and as the angle gets small, these two start to approach each other. That's really what that says. This one's less familiar to you, but you have definitely done it at least 5 times. That one, what does that approach? Well, I guess you better mentally L'Hopital it. It approaches 0. It is indeed approaching 0. Okay, the last is, hopefully, unless you have a really pathetic short-term memory, it is something like, let's use n here. 1 plus 1 over n goes to the n goes to e. Okay? The base goes to 1, but the exponent gets big, and the play between the two starts to approach this idea of e. All right, now then, you're going to do some limit problems like you see here through a little bit of substitution and tweaking to get a famous or known limit using limit rules. This is good proof practice. I totally understand that you could do all these with L'Hopital. You will not do it that way. you'll do it in the way I asked, which is the exercise, okay? So, in this case, this certainly looks like that one, yeah? But there's a little more monkey business going on there. First thing is that the sign and the 2 are in totally the wrong place. What can I do about that? Can I just flip it? Does changing the numerator denominator change the limit? Yeah. But you can. You're actually on the right track, although you clumsily said it. This is the same as that. Do you agree that that is equivalent to the original?
Yeah.
Okay. All right, cool. Now I'd like you to pull off is a U substitution. What do you reckon we should let U equal? We're trying to make it match the original famous limit. Yeah, I guess your 2 choices are, do you let U equal x over 2, or do you let U equal 2x? Which one do you think? You should let U equal x over 2. The sign you really have very little control over. The other one is just a normal algebraic term, and you can bring in a 2 or lose the 2. That one you can play with, but the x over 2 is part of the argument of the sign. There's nothing you can do with that except make it the U. So you should let U equal x over 2, and therefore the sign will become sine of U. Cool. Now, just like any definite integral U sub, we have to account for every change that's made. What's 2x equal to? 2u equals x, so 2x equals 4u. I agree. The denominator is 4u. And a lot like the limits of integration in a definite integral. We need to change the limits. As x goes to 0, what will u go to?
0.
It'll also go to 0. Do you agree they behave in the same fashion? Now, the speed at which they approach 0 probably different, but they will still approach 0. You follow me? Okay, now we talk a little bit of limit rules here. Not 4. Kind of like a definite interval. Do limit rules allow you to bring the 4 out front? They do. This is the same as 1/4 of the limit as u goes to 0 of sine of u over u, all still in the denominator. Didn't use my space very well, did I? So, famous limit. What is this limit equal to? 1. And so this is 1 over a 4th, or 4. All right. Now, in my mind, the work is the star of the show. The answer is not as important to me as the process. It's an exercise in manipulation and limit rules. That's what I would like you to see. So, I think in retrospect, I would rather these all be used. Do you mind? Actually, I don't care if you mind or not. Just do it. Would you change all these to u? I would like all these to be as u goes to, so it's more of a general formula. U to the first. Are we cool? All right. So let's have you try one on your own. The idea is, I think you know you're headed towards what famous limit? Some form of E. The question is, how do you get there? Actually, let's do a little bit of you tell me what to do. So, what should we replace? Okay, so the question is, should we sub here or sub there? Do not sub there. Good choice, but that was the wrong choice. Try again.
X over 2.
Okay, so x over 2 should become what?
1 over x over 2?
What are we shooting for?
1 over u.
The definition is that should be 1 over u there. So we're going to let x over 2 equal 1 over u. That implies then that this inside becomes 1 plus 1 over u. Awesome. All right. What about 1 over x? What does that equal?
Equals x over 2.
X u equals 2, so x is 2 over u, or u, yeah, 2 over u, okay? So it's 1 over x equal to?
U over 2.
1 over x is u over 2, yeah? Are you with me on all those crazy manipulations? Okay, cool. What about the limit statement? If x goes to 0 from the positive side, then what will you approach? There's lots of places to look. But if x goes, let's look here. If x goes to 0, then this is 1 over tiny, which is
Big.
big, and therefore it must be the case that u is approaching infinity. That's good. That was what I was hoping for an E limit. All right. Then, so this is almost the definition of E. The only problem is the,
Over 2.
yeah. Now, here's the, again, where the limit rule applies here. I can, it is 100% allowed to say as u goes to infinity, 1 plus 1 over u to the half is, and what is the inside? B to the, it is the square root. All right. So you're trying to make a u substitution based on the inside of the composite function, and then gradually get to the definition of E or whatever the famous limit is. Try one on your own. Try this before. I have no idea. Who's here? Let's see. So we changed this. 23. How many people know in this class? It seems like it's the teacher. Okay, what substitution did you make, Micaiah?
2 over x
2 over x equals
equals 1 over u.
1 over u. I agree. So the inside becomes 1 plus 1 over u. First step achieved. What is x or 3x? I don't care which. What's x equal to? X is 2u. Therefore, 3x is 6u. Right? Did that change go okay?
Yeah.
What about the limit? These are directly related, yes? So as x gets bigger, u gets bigger. That's delightful. If you isolate, then, is it allowed to say, I'm just going to first say what happens with the u stuff, and then once I work that out, then I'll take it to the 6th? Is that allowed?
Yes.
It is, and therefore your answer is? U to the 6th. Okay. So, on the homework, is it important that you show the process? Yes. If you just write the answer, are you a total weasel who will not get credit? Yes, exactly. Just so we're clear, we're all on the same page. Oh, what's this? I don't even know what's going on now. All right, do you have homework? Yay, what a silly question. Do you have homework to turn in? The answer is yes. Do you have questions on set 100? 10, I heard.
Number 23.
23. Did you say 5? 23, 5, 3, 21, 25,
21? Oh, you already got it.
15,
23? No.
23, no. Thank you for telling me which one she wants me.
No, you already have it.
Oh,
8.
8. So good energy. Did you say 4? Okay, 8 and 4. That's a lot of questions.
It was a hard set. I didn't find except
What? You had 2 sets?
Yeah.
Oh, yeah.
Are you sure?
Who's just do 100 though? Like, or like just do 1?
Are these all from 100?
Yes. It was a hard set.
Come on, people. 99.
Number 6.
4 or less, 3 or less questions. 6, 1. Let's call it good at that.
How do you do 20?
Ay, ay,
One
ay.
question I'm asking you.
20, how should you do it?
We weren't supposed to do 6.
Yeah,
We
you were
weren't-
supposed to skip 6.
Oh, okay, yay. I skipped it anyways.
Good job. It was a
We're not
foolish
supposed to ask the
replacement.
question to skip.
Okay, so 6 is gone. 99-1, do you need 99-1?
Yes.
Is it replaced or straight up full?
Straight up one.
Okay, so you've got a curve at 9 minus x squared and another at x squared minus 1. And you're trying to find the greatest possible rectangle that can be by area fit between the two, yeah?
Yeah.
So shall we make it tall and thin, or wide and fat, or squarish? But the optimization problem should always start with the question, what are you trying to optimize?
Square.
The square in area, the area of the square. Okay, then get an equation. What's the equation for area of it's not a square, a rectangle?
Base height.
Base height. Then, if you can avoid 3 variables, do so. Is there some kind of relationship between the variables that gets it down to 2 variables, not 3?
Probably.
What is the base?
Oh, it's 2.
2x. What is the height? 2 y's. That's true, I suppose. 2 y's in a fashion, a little more. Okay, upper minus lower. Yeah?
Yeah.
So the upper is 9 minus x squared, and the lower is. So it seems like the easiest way to go about this would be to, oops, that's 2x squared. To maximize this area, yes?
That's what I used it for.
Does that get you started? Now find where a prime goes positive to negative. Does that get you going? Yes?
Yeah, I think it's
9 minus negative 1. You're right. 10 minus 2x squared. Thank you. Yes. It's about the same whether you use product rule or distribute first. It's your call. Are you good from there? 20. 20. Is 20 still a question?
Yes.
20. How did the differentials questions go? Are you getting that? Is 20 a replacement?
Yeah.
Yeah.
Okay. And it is inequalities. All right. I put this on as a precursor to delta epsilon proof, which we're going to do this week. You have to have some major league skill to do a delta epsilon proof with inequalities, because it involves a lot of inequality work. For the time being, however, I just want you to focus on the algebra. This has meaning to it. It's really how you prove a limit is something. But right now we're just going to focus on the math of it. Now when you prove an if-then statement or show an if-then statement to be true, you start with the hypothesis of the if-then, and you try and, through accepted math rules, get to the end result that it must be the case that this has to follow. This must follow as a consequence. So we're trying to go that if we assume this to be true, it must follow that that's true. You with me on the question?
Yeah.
All right. Now, it might help you to get started by saying, all right, well, I'm not sure exactly what I'm trying to get to. Look at the step right before that. They tell you what f of x is. F of x is negative 1/3 x plus 1. So wouldn't you say that if I could take this and make it negative 1/3 x plus 1, then I'd be home free because I could just replace that thing with f of x. You see? All right. Now that might help you. I'm trying to get from here to here. What should I do to each side to get there? Multiply by 3. Good try. Try again. 1/3. Almost there, but not quite. Okay. Now you want a negative 1/3 in absolute value. So I'm cool with your third. Actually, I'll take your third. Did I break math or am I cool? Okay. So I'm cool. All right. Will you agree that 1/3 is the same as the absolute value of negative 1/3? Would you agree that those are the same?
Yes.
And would you also agree that 1 times 3 over times 1 times 1 over 3 times 1 over 10 is 1 over 30?
Yes.
So I didn't break any math. I am cool. I follow the rules. Yeah. Okay. This might be a rule that you're not familiar with, but I'll tell you. What if you have the absolute value of two numbers and you multiply them? Isn't it the same as if you multiplied them then took the absolute value? Is that true? It is true. It is the same. These are the same. So how does that help me here? Absolute value of negative 1 over 3. There, yeah? In other words, I could put them in the same absolute value. Follow me? If I were to multiply that, I'd get negative. I need more room. I should have just grouped it. Whatever, it's fine. Okay, so this is the absolute value of negative 1/3 x plus 2 is less than 1/30. Last but not least, do you agree that 2 is 1 plus 1?
Yes.
Well, there you go. We're done. All right, now, what all that means, besides a whole bunch of symbol pushing, I'll get to that. But for now, just master the symbol pushing. You down?
Yes.
Okay. Let's move on to set 100. Set 123. Do you have that question still, or did you have an epiphany?
Still have the question.
Oh, no epiphany.
Not since like. Oh wait, it's the same question.
23 book or replacement?
It's a replacement.
It's a replacement, but the same idea. So now, you're going to be able to do this. It'll be great. So they tell you f of x is 3x plus 3. Show if x minus 1 is less than a tenth, then it must follow that f minus 6 is less than 3/10. Okay, so what am I starting with? Assume. Do I assume the first part or the second part? Assume the first part. If you can start with the first, it must follow the second. The second should come as a consequence. So, I'm trying to get to this step. F of x minus 6 is less than 3/10. What should I do? F of x is 3x plus 3. Now this is, you remember all those identities you did in the green book? The answer is yes, because the sheet is right there. You see?
Yeah. Thanks, Mr. Sheena.
Right. Okay, so do you remember those identities? You should really only be working one side, but sometimes when you get stuck, it helps a little to peek at the other side and see where you're trying to get to. That's kind of what I did here. I kind of peeked at the other side to see where I want to get to. But let's now talk about how I would change x minus 1 is less than 1/10 and get it there. What should I do? Look at the x. I want to do what? Add 3. Did you say? You didn't say that, did you? Multiply by 3. If I multiply both sides by 3, is that mathematically sound?
Yes.
It is. if the 3 is outside, it can be brought inside. Yeah, 3x minus 3 is less than 3/10. That's true too. And is it true that negative 3 is the same as positive 3 minus 6? Yeah, it is the case that negative 3 is the same as positive 3 minus 6. And if,
I do it a different way than Mr. Rickman.
I will have to look at what you do. If you're saying I work backwards, the answer is yes.
But like,
Correct, what do you mean correct?
the other
The
ones that
answer
we've
is
done
yeah.
before was correct, but then I got a different answer for that one.
That's
Like the
cool.
ones that we did before.
Yeah,
I
no.
just did it a different
How
way.
could
Yeah,
you get it?
so if you're starting here and going that way, that is a no.
See, I tried with X and then
You start with X and work towards F, not vice versa. All right. 5. Question on 5. 5 is a yes. 5 is a yes. 5 replaced or straight up normal? Replaced? Replaced. Find the error bound for your estimate in 4. F double is ugly. You may use a calculator to find the max of it once found. What does that mean?
Ooh, that's not nice.
Okay, so 0 to 2. Is this what I have here? Yes.
You can't just do that one, it's just wrong.
I do what?
What?
Oh, I thought you were talking to me. Okay, so this is what you did at number 4. You estimated the area under that by trapezoids. You follow me? Okay, so number 5 is, what is the error bound for your estimate? When you use trapezoids, what's the upper bound for your error? Less than or equal to? Whose question is this? Why am I wasting my time? Help me.
I don't know if you minus
B minus A cubed over 12n squared times m, where m is max of the absolute value of the second derivative on the interval. So on 0 to 2, yes? All right. So we'll throw in what we have. B minus A is 2 cubed. N is 6. And then we get to the point where we need it. You're allowed to use your calculator. So what's the most expedient way to find the max of the second derivative on 0 to 2 using your calculator? What did you do? You graphed the function, or you had the calculator do the derivative of the function, or the derivative of the derivative of the function? You went to the calculator and said, hey calculator, take the, what the heck? Take the second, why is this, go away, there we go, okay. So, you said, hey, take the derivative. This is gonna, is your calculator gonna, oh, you're saying take the derivative of the second derivative? Ah, I got you. So I need the function in first, yeah, what is it again? 1 divided by?
1 divided by the square root of x squared plus 1.
Square root of x squared plus 1. You gotta be careful here. Sometimes these calculators will get locked into battle with this and get in a loop. So you say let f2 equal the second derivative with respect to x of f1. Is that correct? Mon ami? Okay, now let's talk on 0 to 2, shall we? Oh, maybe I should have taken the absolute value of that. What do you think?
Yeah.
Darn it. Can I take the absolute value of that?
I mean, you don't need
Or are you just going to find the min on 0 to 2 and call it good? That's pretty obvious. Maybe to you, Miss Smarty Pants. What is the max?
everywhere else is like 0.
The max of the absolute value is 1. All right, I agree. So m is 1. You follow me?
Yes.
So the error bound is... What'd you get? Did you get something like 154? Yes? Okay. 3. Question on 3. Is 3 still a question? 3 is not a question. Excellent.
Wait, no, Rich, still a question.
Okay. So here is your graph. Part A says illustrate C for, or estimate C for the mean value theorem for derivatives, yeah? So what does the mean value theorem for derivatives say? What's the concept? I don't know, man. I just know the formula. I punch stuff around and it all works out. What does it mean? Slope of secant equals the slope of tangent. Here's a place where here's the secant slope, or the average rate of change over the interval. Is there a place where the tangent slope must be the same? How many places roughly? About. There's one. There's a tangent slope about the same as that. Maybe one at there. Did you say one at there? I didn't know this scale very well. This is kind of a borderline. Did you do one here too?
No.
You just said here. So there might be one here. But this one, where did you estimate the C at? C is roughly 1. Definitely not 1, because 1 is, it's not a horizontal tangent. All right, 1, I agree. 1, I'm down. All right, cool. Now the second question is same graph. Estimate the C for the mean value theorem for integrals. What does that have to do with anything? What is the mean value theorem for integrals' big idea? There has to be a place where the average value is made. Where did you say ballpark the average value is? Average y value is roughly in here. Did you say something like that? So that the average y value is such that all the overage and all the underage is about canceling each other out. So how many C's did you have here? You should have roughly a C there or here where the average value is made. So what kind of C's did you say? One close to zero-ish? Maybe what? Negative 0.25, okay, and then one a little more on the positive side, so C of 1 1/3 or a third. Okay, I said C is about negative 1/4 and about 1 1/4, but something along those lines is an estimate. So as long as you have 2 where the average value is, you're good.
Okay.
21, is 21 still a question?
Yes. Yeah.
21. The side of a cube is measured as 10 centimeters. However, there could be error. How accurate must the measure of the side be in order to get the percent error estimate of the volume below 5%? Oh, that's a humdinger. What do you say? Did you get started? How do you do percent error? dy over y times 100% to make it a percent, right? In this case, for volume, percent error is dv over v times 100%, and it has to be less than 5%. That would imply that dv over v has to be less than 1/20. Yay? You down? What is dv? Let's go with a cube equation. What is it? V is x cubed, okay? So don't we know that v prime is dv dx? So dv is v prime dx. The rate of change times the amount of change in x give you an expected amount of change in v. So dv is v prime dx. V is, well, I'll come to that in a minute. Let's just nibble away at it. What is v prime? 3x squared dx. So what is V? X cubed. Alright, we're getting there, we're getting there. What am I trying to find, and what do I know? What am I doing? What can you do next? What? Plug in? You want to simplify a little first? Let's do that first, shall we? Do you mind if I take out 2 x's? Alright, now plug in. Plug in what? X. I know I measured the side at 10 centimeters. Now, in order to get the error less than 5% in the calculation of the volume, I would have to get the measurement of the side pretty accurate. How accurate? That's the dx, and that would be, can I multiply both sides by 10/3? Okay. And if it's an absolute value or if it's positive, I'm good to go as far as not switching the inequality. I should be okay there. So dx is 1/6. So let's answer then our question. I would need to measure the side with error less than what? 1/6 of what units? Of a centimeter. Okay, if I got the side within 1/6 of a centimeter on each edge, then I would get the volume within 5% of the true. 20, those are hard. Those are tape practice. That one was a little harder than most. I pulled that from the Minds book. That was 21?
Yeah.
25. Is 25 still a question? Yes? No? 25? No. How about 815? 15's a yes. I didn't hear anything. You lost. You guys. 15. I'll come back to you in a second. 15. The base of a solid. Oh no, 15's replaced. Ooh, 15's a good one. It's really important that you give this a good go because the AP test has gone this way. Oh, too bad. After I said how important this is, we don't have time. Sorry, see you later.
Bye. This is important. Good luck.
Yep, pretty much. Yes, you have to turn it all. We did 5 questions. What do you want?
I would like you to hold my hand and walk me through the entire
Exactly.
set.
Why don't you just, I'll tell you what, just turn it in blank and I'll write it all in for you, okay? And then we'll-
Perfect.
Yes, you have to turn everything in. Go. Have a nice day. I don't know. Let's see. Yep, you're on the right track. Have a lovely day.
Do you ever think it's after school since John's
I am here after school, yes.
Very fun. I got the
Oh,
link.
you guys are such a pain. I can't believe you went through all this.
I feel 3 pomegranates and Patrick's blood sisters.
How many licks does it take to cover the whole surface area? Volume by licks. Yes, we're doing volume by licks.
Ah, sorry.
It was so awkward. I almost sitting next to him because I times next to it. It's expensive.
So I made a new 80/20
Actually, no, I probably didn't. So I sat for I went to the first one, which was really is she not here? I was like, wait. Something she said. Like watching a video of someone watching
I love the work that I was choosing the last one. I should have been having them. I feel if I said, you take this and put it in the order, maybe third.
That, we know this last year, and we're going to put this to you, tomorrow. We had a warm up on our Jesus, some stuff is in the box, it's actually on the slide, I saw it.
Hey, if Senora can realize that I'm saying that though, that thing mentioned me. He was like, are you okay? And I'm like,
Do you think they're trying to sabotage it? I think there was either my kids got killed on that. Why do you think we put him in last year afterwards?
Her scores are way better than mine. Way better than
I've
mine.
already told you.
she fudges the most of it.
But I told you. I said, you did you write to me? I go, and I'm like,
Because their sports class
Yeah.
it says my you're both missing and you can come back.
I will record them. All right, let's do a warm up here really quick. Set 101. That's pretty cool that that happens on today. I mean, 101 and today's 11/11. Oh, this is the biggest shopping day of the year. It's Singles Day. You know this? So in China, the guy who created Alibaba, the right one, which is like the world, he created this anti-Valentine's Day thing. It's basically because he's a great businessman trying to get business. He said, on Singles Day, you buy yourself stuff. You have no love of your life. You buy yourself whatever you want. He made this holiday up, and now this is the biggest shopping day of the year. Singles Day, 11/11. See singles, get a 1/1. Whatever. Why do I waste my time with it? Let's just talk math and nothing else. Let's live our own little math box, okay?
Let's do calculus.
Let's just do calculus and nothing else. Kaka, I will not even speak. I'm just going to write calculus and you write it down and we'll all be happy. All right. Warm up. Do you remember how to integrate tangent? Or do you remember the antiderivative without showing the work?
We don't have a 9.
Oh, good. That's a waste of your time anyway. 11. Secant. Do you remember how to do that? If you had to show the work, do you remember how to do it? Okay. So I hope you haven't memorized it, because you don't remember how to do it. Do you not have 11?
It's a little bit off.
What? Are you sure?
Never use the hospital on a different.
No, I didn't say it. I just wanted to remind you, I was going to remind you, make sure you don't use one call. I didn't say it has something to do with what. No wonder the other parts are so confusing. Ignore the memo that has nothing to do with the problem and do this problem. Do you remember how to do it? It takes a creative multiplication step. Do you remember what you multiplied by? Secant plus tangent. So that the numerator becomes secant. Geez, you guys are killing me. Secant squared plus secant tangent over secant plus tangent. Okay, then what should we let u equal? Secant plus tangent. And therefore du is secant squared plus secant tangent, actually probably in the opposite order, but it's addition, so it doesn't matter. So that the problem becomes 1 over u du, the antiderivative of which is natural log of the absolute value of u plus c, and then our final answer then, the natural log of x plus tangent. Sweet. All right. Not quite warm, I must say, so let's try another one. Oh, maybe that's what the problem was. Oh, I was on the wrong set. Oh, can we erase that?
No.
I was definitely on the wrong set in the last class, and they said nothing.
Because they're weird.
Why would they do that to
I
you?
don't know. They're just all-
Why would they do
Show them superior.
Ah. Use the box. Work at home. I don't need to pay for myself. I'll just do it if they tell me to do. Wow, that's sad. Okay, so the other problem, I guess I want to emphasize that is actually on the problem set is 7. Hi. Hi, Lily.
I'm good. How are you?
Fine. So nice to see you. 7 is the function is e to the absolute value of x. Find f prime. I'll let you do that on your own. It is different that the absolute value is not on the entire function, it's just on the x. She's not in here. What the heck? I can't. Where is it? Oh. There's some different seats now. I don't know why. You might start. It might help to start with the graph. To remind you of the big ideas. Does this cause a flipping up of the graph? No. Big ideas, the universal ideas for absolute value are it does nothing to positives and it changes the negatives. So because it does nothing to positives, what will be unchanged as far as the normal e to the x graph? Positive x's or positive y's? X's. So you're saying this stays the same, yeah? Okay, great. The negatives will change. When you put in a negative in for x's, what will happen? So if it made like positive, so graph-wise, what should I see? It's more like a symmetry idea, like that, yeah? Okay, cool. Now in a piecewise function, the left side, what is it without the absolute value? Is it negative e to the x? E to the negative x. Take the x and make it positive. I agree. For x is less than or equal to 0. And what about the right-hand side? Just e to the x. No effect. And again, you could equal 0 on either branch. I don't care. That's continuous, so it doesn't matter. Therefore, the derivative for the left branch is negative e to the negative x for x less than. Do I include 0 now?
No.
Why not?
Because it's sharp.
Sharp turn in the right-hand side? E to the x. X is greater than 0. Alrighty then. Good stuff. Let's also do as a warm-up number 18. Use differentials to estimate the cube root of 60. Do you need help getting started, or you got it?
Yes. Help.
Okay, so let's let y, or the function, equal the cube root, right? When you do differentials to estimate, you're estimating change from some known point to some new point. What is the known point we could start from that's close to the cube root of 60? Cube root of 64. So this would be like the cube root of 64 plus some change in y. That delta y, when you talk the actual true change, that's delta. The differential idea is that you estimate the true change with the differential. So this would be like the cube root of 64 plus differential time, dy. All right? That's one of the two big ideas of differentials, is that dy's or differentials can be used to estimate true change. The other big idea is that if the derivative is a rate of change, dy dx, then amount of change in y can be found by taking the rate of change and multiplying it by some amount of change in x to get an amount of change in y. So in our next step, we could replace this with the cube root of 64 plus dot, dot, dot. This is where you speak. F time of x. Let's call it exponential dx. Okay? Cool. Cube root of 64, at some point we could do that. It's starting at 4 and changing some. What is the derivative? 1/3 x to the negative 2/3, which would be x cube rooted and squared in the denominator. Yeah? At what point? At x equals 4, 64, 60? 64 is the original good, clean starting point that I put into the function. Dx, how much am I changing x by in going from 64 towards 60? 4? Negative 4. Now that's the only way we're going to get a decrease, which we know needs to happen. Cube root of 60 needs to be less than cube root of 64, right? Okay, so we're almost there. 4 plus, how's the denominator come out? What's the cube root of 64? Squared times 3, 48 times negative 4. So seems like 4 minus a 12. So 3 and 11 plus. You follow me? Yes. Okay. We are going to get to about set 112 or 113 before Christmas break. This week we'll, kind of a weird mixture of sets. Self-epsilon proof is where we're headed. That's one of the harder concepts, but we'll build up to it and break it into 2 days. You'll be fine with practice. So this is in the wrong order. Would you pick up those notes and let's start there. Let's start with, what is pi?
3.14.
That's not what it equals. That's not what it is. It's the ratio of the circumference to the diameter. Okay? So if mankind never existed, would pi exist?
Yeah.
Yeah, I mean, there'd still be circles, I assume, and still be diameters, and there'd still be pi. So pi is not a dependent on mankindly kind of creation. It's just a naturally occurring phenomenon. You follow? And I guess mankind discovered that it was there, but we didn't make it any more than we made the moon. It was just there. The same goes for E. E is a naturally occurring number, and that is the big idea of the day, or one of the two big ideas of the day. To introduce where E comes from, let's go here. Say you invest $1 at 100% interest compounded once at the end of the year. How much would you have at the end of the year? $2. I'm sure some of you are shy, or if you thought that question was beneath you, or you really just don't know the answer. That's scary. But the balance after 1 year is, now I'm going to write it this way in the interest of getting there. I'm going to take that dollar, and as far as what I get back 100% of what I started with. I get the original dollar back, and I get interest. That's the 100% original back plus 100% interest. And so I get that dollar grows by a factor of 2, and I get $2 back. You with me? Or changes by a factor of 2, not grows by a factor of 2. I said that incorrectly. All right. Now, say then somebody comes on and says, you know what, this is sucker money. After 6 months, you've had my money for 6 months, and you've been using it. I want my interest for the first 6 months, so that the second 6 months I can get interest on interest. Now that would mean compounding twice. I don't like at all what I did, so I'm going to do this. Balance at 6 months. Now you're going to take $1, and you're still going to get 100% of that back. But in terms of the interest, won't you get 100% interest, but actually only half that, because that's 100% for a full year, and you've only had it in for 6 months, right? So after 6 months, you would get 1 plus a half. Or at 6 months, your balance would stand at $3.50 or $1.50. Do I think? Now for the second period, or the second 6 months, you would take your previous balance, and it would grow by 100% plus a half of 100% for a half of your interest. And so if I took that previous balance, which is 1 plus 1/2, and it grew by a factor of 1 plus a half, after a year, wouldn't you have 1 plus a half? All right, so 150% of 150%, which is 3/2 times 3/2, or 9/4, which as a decimal is $2.25. Yeah? Cool. Now, somebody smarter than that guy, probably a woman, said, you know what, forget this interest twice a year, let's compound it 3 times a year. Now, each time, you would take $1 or the previous balance, and you would get 100% back, and then for interest, you'd get 100% interest, but only for a third of the year each time. So if you do 133% the first time, then 133% of 133% the second time, and then 133% of 133% of 133%, it's 1 plus a third 3 times over. Now that then is 4/3 cubed, and what do we got there? Let's see, 64 divided by 27 is not very illuminating. 2.370. You follow? Okay, so that person gets $2.37 at the end of the year. What if you compounded it 4 times? How would you calculate how much you had at the end of the year? You get 100% back, and each time you get 100% interest, but divided for how much of the year, and you've only left it in for a fourth of the year. So when you compound it 4 times a year, you get 1 plus a fourth, or 5/4 to the fourth. 5 divided by 4 to the 4, approximately equal to 2.441. That's pretty good. You're making a lot of interest on interest now. By doing that, you made an extra 44 cents in interest by earning interest on interest, yeah? What about every 12 months? How would you calculate it?
100 plus 112.
to the 12th. 13/12 to the 12th power. 13/12 to the 12th is 2.613. Even better. It seems at this point, somebody probably said, if you just keep continuously compounding, you're going to get rich. You'll get infinitely many dollars. Does it go without bound? Well, let's see. What if you compounded daily? 1 plus 1 over 365 to the 365. So that is 366 divided by 365 to the 365. Oops, darn it. To the 365. 2.714. It's still growing, but it's not growing as fast. Yeah?
Yeah.
It went up by, originally 25 cents, but now it's only going up about 7 cents, 10 cents. So what about if every hour? 1 plus 365 times 24 hours a day. Let's do that. Times 24 times, oops, that's addition, 20 times 24. Oh, what? Oh, what? Oh, sorry, this is bogus. I didn't change the numerator. Sorry. 1 plus, what did you say? 1 divided by 365 times 24. Nope. Sorry. Anticipation is killing me. How about you? 2.7181. We could continue this. 2.7181, but I think you'll agree that while it is getting bigger, it is seeming to reach an upper limit. The question is, what is the upper limit? Well, that is where E comes from. E to the first is the naturally occurring number that comes from taking the number of subdivisions to infinity. Let's call it, as n goes to infinity, of what? 1 plus 1 over n to the n. That's E. Now, over here, this unfortunately, he does the book in kind of a wacky order. But what does, forget the E for a second, what does this base go to? As n goes to infinity, what does 1 over n go to? 0. So what does the base go to? 1. And the exponent goes to infinity. Going to 1 to going to infinity is an indeterminate form we haven't covered yet. But it usually involves E. It might seem like, obviously, exactly 1 to the infinity would be 1, but approaching 1 to the infinity, well, that's a little bit of play between, yeah, the base is getting closer to 1, but the exponent's getting big. What happens? Well, that's the play in between kind of thing. All right, it usually involves E. So, here's the second idea of the day. That's where E comes from. The second idea of the day is manipulating a known formula. Now, this is a useful skill for all levels of math, but especially in college. If you, I don't have a college text, but if you look at a college calculus text, they typically at the back of the book probably have 5 pages of templates or known anti-differentiation rules, known integral rules. The idea of being able to take a known antiderivative rule and play with it, tweak it a little to fit your problem is a skill you've got to have at the upper level. So that is what I'm going to focus on here. How do you take something you know to be true and make your problem that's kind of like it, but not quite make it look like that? Let's start with, as an exercise, let's start with 3 big famous limits that you should know. And then the first one is the most famous limit of all, is probably the limit as u goes to 0 of sine of u over u. You have seen that a million times. U is, or sorry, this limit is 1. Now we could do that by L'Hopital, if you like. We could do it by calculator and see what it approaches. Make a table. We could do that a lot of ways, but you really just need to know that. The second one is a little less notes. This is, yeah, that's right. The second one is a little less known. It's as u goes to 0, cosine of u minus 1 over u. You might not know that one off the top of your heads because you've only done that about 10 times in your life, probably. But if you had to, I guess you could L'Hopital it up and then answer. What does it go to? -1. Good try. But no. Try again. 1. It's 0 over 0, so it's indeterminate. L'Hopital would be appropriate. What's the top derivative? Negative sine of u over 1. And as u goes to 0, negative sine of 0 over 1 is 0. All right. All right, the last one is the one we just talked about. The limit as u goes to infinity of 1 plus 1 over u to the u is e. All right. Now, on the homework tonight, you're going to get problems that look kind of like one of these three, but you're going to have to, it's kind of like an identity. The question isn't so much what's the answer. You might have a clue what the answer is. The question is, can you show how the answer comes about? That's the skill here. So, let me give you a couple examples, and then you'll do one on your own. So, say this problem is given. The limit as x goes to 0 of 2x over sine of x over 2. It says evaluate the limit using a u substitution. Notice it doesn't say use L'Hopital to answer this question. Is this a L'Hopital question at all? It is. It's 0 over 0. So L'Hopital could be used, and if they didn't say, then I guess I would use it probably. But they're clearly saying do this exercise of u substitution on the limit. U substitution is used in lots of fields of math, not just integrals. So it goes a little like this. The first getting started is to make it a little closer to what you're used to. I'm used to having sign on top. Okay? Can I just say, hey, I feel like flipping this. Here I go. Is that a math rule? It's not so much a math rule. What about this? Is this equivalent?
Yes, it is.
Isn't that equivalent to the original problem?
Yes.
Okay. Now, this goes to limit rule. If I wanted to know what the limit of this stuff was, would the 1 be doing anything but just sitting there waiting for you to finish about the function stuff? So you're saying I could really just focus on the function stuff and then put it under 1 and you're good. Yeah? In math terms, then you're saying I really need to just take the limit on the function stuff, and once I evaluate that, then that is the denominator of my answer. And that is allowed. That is a limit rule that is used frequently. You down? Okay. Now is where we're ready for u substitution time. What u shall we call 2x equal u and sub for the bottom, or x over 2 equal u and sub for the top? Well, you're absolutely right. X over 2y. Yeah, it's the inside function. I can play with the 2x all day long. It's a normal algebraic term. I can manipulate it all I want. But, man, once I put something in for sign, there's no way to balance or anything like that. The argument of sign is just, it is what it is. So you should let u equal x over 2. When I do that, then, this becomes sine of u. That part does. And just like any definite integral u stuff, you have to account for everything. So let's go to 2x. If I let x over 2 equal u, then isn't x equal to 2u, and therefore 2x equals 4u. So the denominator would be 4u. And last but not least, just like when I change my limits of integration to fit u, same goes with the limit. Look right here. For the limit, if x goes to infinity, then u must also go to infinity. They're directly related. And so it is the same as if I said, what happens to this problem if u goes to infinity? You follow? You're almost there to famous limit time, but the 4 is a problem. Do limit rules allow you to move the 4 out front like you would in an integral or a derivative? They, oh, sorry. It is 0. Sorry, my fault. Sorry about that. Okay. Limit rules absolutely allow you to move the 4th out front. I just really want to focus on what the function part of it is. So I could move the 4 out front and say, what's the limit as u goes to 0 of sine of u over u? Now we're ready for that famous limit. That limit is 1, oops, I wrote this wrong. Isn't it 1/4 in the denominator? So that's 1 over 1/4 times 1, which is, and most importantly, it's not the answer, it's the process. All right, that's a sine or trig type. Let's do an exponential or e type. This, I think you'll agree that this is close to fitting the u model, yeah? So let's start with the u sub. What shall we shall we look at this and try and make it 1 over u, or look at the 1 over x and try and make it u? Look at the inside, the composite function, not the 1 over x. Look at the composite function. So the inside is where you should do your u. You should look here for your u choice. Now, we want this to approach or become, to fit the definition, x over 2 needs to get replaced by 1 over u. So we're going to let the reader say, all right, let x over 2 be equal to 1 over u, so that the inside fits the pattern, all right? Now let's make all the corresponding changes here. If x over 2 is 1 over u, then what? X is 2 over u, and so 1 over x is, are you with me? If x over 2 is 1 over u, if I move the 2 out, then x is 2 over u, and if I take the reciprocals, 1 over x is u over 2. So the exponent becomes u over 2. Last but not least, as x goes to 0, u goes to, now these are inversely related. As x gets small, u gets big, and because it's approaching from the positive side, u would approach positive infinity. All right, now we're talking. We're so close to looking like e. What's the problem? The over 2. So question for you. If I wanted to see what this approach is, could I just say, what does the 1 plus, could I do this basically this way? Could I say, I want to just first focus on what does this equal, and then take that to the half power. Are those the same? Yeah. And what about the limit? Could I, instead of doing the half first, could I say, what does this thing equal? And take the limit of that, and then take the half power? Is that okay? It is okay. So the limit as u goes to infinity of 1 plus 1 over u to the u, and then later on take the half of that. That is okay. And so our answer is this limit approaches e to the 1/2 for the square root of e. Okay? That is the idea. The only way to get good at these is to try them. So you try.